So welcome to my talk about advanced Eventmachine. I'm from Berlin, Germany. We do a lot of work around deployment and scaling because we work on Scalarium, which is an Amazon EC2 cluster management solution where we handle lots of connections and manage thousands of machines. And this is like the way we discovered Eventmachine and started to use it. And the idea of the talk is to describe a couple of patterns we came across and a couple of situations that you should be aware of if you use Eventmachine. Before we dig into Eventmachine, who already uses Eventmachine? Oh, so quite a few. Good. So I can keep the introduction pretty short. Yeah, so Eventmachine, as it seems a lot of you guys already know, is a very simple and event processing library for Ruby. Kind of, the Node.js for Ruby, if you want to. So the idea is that I can have a lot of multiple I/O streams without blocking on them so that I can execute them what looks like in parallel. And the whole programming of Eventmachine is done via callbacks. So very similar to Node.js. And the cool thing about Eventmachine is that it already brings a lot of protocol implementations for the typical stuff like UDP, TCP, HTTP, SMTP, and so on. So it's very simple to use. And because it's Ruby, it's very easy to extend and to reuse your existing libraries, which is also kind of the culprit of it, because it's very easy to break it if you use existing libraries. It's very tempting, as we'll see in a couple of minutes, to just require a gem, and without knowing it, everything gets slow, and a lot of unexpected things happen. Yeah. So this is what you should definitely have a look at. You have to think before you use or require a new library. So the basic idea is turning like synchronous, step-by-step, sequential code like this one into callback-oriented code where I call a command and register a callback that will be called once the command is finished. And my code can move on. So it doesn't block on the load data call. And I get notified once the process is finished. And this idea is pretty simple. I mean, people, especially in the Rails community, know it like if you program JavaScript in the browser with like DOM notifications and stuff like that. So it's nothing too unusual. But it's pretty easy to get confused once you have a very deep nesting of callbacks. But the simple idea is very simple. So let's maybe like step back and explain to you how we came across Eventmachine and why we started to using it. Our simple use case was we process a lot of events, and all of those events we generate log files and we store them on Amazon S3. So the basic idea is somehow we generate a log file and we have millions of those, and we then want to upload those to S3. So the typical step would be just a sequential call. You have a log file, you post it to Amazon S3, you wait while you're uploading, you wait while Amazon is processing the data, and then you get a response back that says, I've got the file. So nothing fancy here. But if you have a lot of log files and you do it with a lot of files, it looks like this, right? So I upload a file, I wait for the upload, I wait for the processing, it's done, okay, let's take the next one. Yeah? Upload the next file, waiting, I get the response, so I can upload the next one, and so on. So the time it takes is the sum of the individual times. Yeah? So it takes me a long time, and for most of the time, my process is just sitting there waiting for networking, waiting for Amazon to respond. If you do this stuff like this with Eventmachine, the picture is a very different one, because I can now upload multiple ones at once. Yeah? I then get the first response back, I can upload the next one, and then I get the responses for all the other ones back. So the time that I'm spending is like roughly like the maximum number for the individual. I have to wait for the longest request. Yeah, it's only roughly because it depends like on how many parallel processes you're doing it and on other things, but you can optimize this a lot with stuff like that. So for example, in our case, we had like I think a 6 times increase in throughput of managing all of those log files, just by doing it with Eventmachine. So this is the theory behind it. We also wrote a small library to do it. So this is like the code if you would do it first with write WS and then with happening, that is a small library that we wrote. And as you can see, you have a little bit more boilerplate code in order to get Eventmachine running. So we have EM run, and then at the end we have EM stop. But the actual code is not so much different, apart from the callback part where I wait for the response to come back to me. If you're interested in happening, it's, as I said, a small library. So apparently the important thing about Eventmachine is the event loop, right? It's in the name. And this was for me the most important thing in order to really understand how Eventmachine works and where the culprits are, is to really understand how the event loop and the corresponding threads are working. So the setting up the event loop is pretty easy. You just call em.run, and at some point you stop it again. And em.run is an endless loop. It will start the Eventmachine loop, and it will not return unless you stop it. So if you have like small parts, small agents, small daemons that are running Eventmachine, usually this is like the first and the last call that you're doing. Yeah? You're calling Eventmachine, and inside the loop you're setting up your callbacks, and then you do nothing and wait for Eventmachine to process all events and come back to you. What you don't see is what happens in the background is. So your code is actually a very small part of what is happening. But your code can break anything else. And this is, unfortunately, the thing that you always have to have in mind if you program with Eventmachine is you have to be very careful what your code does and where it does it, because it's very easy to break the loop. So what you do with your code, you register your callbacks. And during such a loop run, what Eventmachine is doing is it's running all timers that you registered. It's checking file descriptors. It's checking sockets, networking, stuff like that. And then it calls your code if necessary. And then the next iteration starts. So the whole idea is this loop is endlessly running and always in this line. So checking file descriptors, checking networking, your code, if, any callbacks that you registered, and next round. And what you have to keep in mind is that you should not disturb this cycle. And unfortunately, it's very easy to do so. But if you disturb it, if you somehow break it by your code being too slow, everything falls apart. So how can you break it? And what you shouldn't do is stuff like that. Yeah, putting in the main loop like a sleep. Yeah, of course nobody puts a sleep in there. But doing any synchronous call is pretty much the same thing. We're now blocking the main event loop because we're waiting for an HTTP call. And if this server that we're getting the response from is very slow, everything is waiting on this server. So so you shouldn't do any synchronous calls inside the event loop. And this is the part where I said in the beginning, it's very easy to break it, even by not knowing, because if you have a class that is running somewhere inside the event loop, and you just need a small new functionality, and you just require a gem somewhere that does a couple of HTTP calls, that does some networking, whatever, it's very easy for this code to sneak into the event loop, and then you're wondering why is everything processing so slow, why are the messages piling up, because you block the loop. So an example case how we did it, for example, is we use Nanite, which is an agent framework on top of AMQP, Eventmachine, and RabbitMQ. And what it does is it distributes messages across agents. And we pretty much broke the whole setup by just having the default behavior of the AMQP gem, which is if there is data on the socket, it reads it. And if you have a lot of messages, a lot of data, it reads a lot, which means if you look back to the loop, if the reading part becomes too big or too much work, you're slowing down the whole loop. So our code was essentially like reading thousands of messages. Then we had one iteration, which means like callbacks were notified once, and then we again reading thousands of messages, which means we slowed down the whole cycle, which means effectively everything is running to a halt. And we did it by just using the AMQP gem, which is already evented and stuff like that. So it's very easy to do it. So what we need to do is to somehow split the work and make sure that our code is not running for too long. And And how you can do that, I will show you in a minute. But the main idea is that inside the main reactor loop, which is the main thread, you shouldn't do anything that is slow. You shouldn't do anything that could potentially block it. You shouldn't also, if you're not calling any synchronous code, only asynchronous code, you still shouldn't do anything that takes too long. Because as I just showed you, in our case, we didn't do anything synchronously, but because it was so much work, we still blocked the loop. So the main idea is to try to keep everything as short as possible, also to do all I/O handling inside the main loop, and avoid non-evented libraries. I cannot stretch this point too much because it's so easy to just require a library. This is also like why I think Node.js is like more successful in invented applications. It's not because they have a better programming model, better libraries, whatever. It's just because they enforce on you that everything is evented, so there is no like synchronous library that you can load. While on Ruby, if you just like do like a file.open operation, yeah, you just use the basic libraries that are part of the standard library. You're already using something synchronous that is blocking you. So yeah, take care and do not use anything that is not evented. And the other thing is, as I said, your callbacks are running as long as they take, so make sure your callbacks are not taking too long. Because even if you use evented callbacks or evented applications and libraries inside your callbacks, if they take too long, you're still blocking everything. And one nice way to do it, how you can break up those in smaller steps of work, is to use EM-Next-Tick. So EM-Next-Tick, you give it a block, and what it does is it schedules it to run in the next iteration of the loop inside the main reactor thread. And what you can do with it is, for once, you can like come back from a background thread. Or the other thing is, you can, if you have a very big piece of work that you need to be doing, like reading thousands of messages on a socket, you can just like read a couple of messages and then reschedule yourself to run in the next iteration. This is an example how you can do it with a simple proc and a method. So let's assume do something is potentially slow or like potentially processes a lot of work. So we can just call it every couple of only process a couple of messages and then reschedule ourselves to call to be run inside the next iteration. Yeah, so this is what EM-Next-Tick does. The other thing is it brings you back from a background thread, and what it means we'll see in a second. But this is like one of the important concepts is every time you use I/O, like wrap it in next-tick. This will ensure that you run inside the main loop, inside the reactor thread. There are cases where you don't want to do this, or there are cases where you want to do something slowly. Or I have to compute like the Fibonacci number of 2 billion or something, yeah, and it will be slow. So what you should do is wrap it in an EM-defer block. EM-defer does the opposite of EM-Next-Tick, so it brings you out of the main reactor thread into a background thread. By default, there are 20 threads in a thread pool that you can use for it. And EM-defer will make sure that this code that you give it runs in such a background thread. So in our example case here, we will not block the main loop. If I wouldn't wrap it in EM-defer, we will never see like the continuous printing of the timer, because we will be blocking the main loop, because the sleep will block the loop. And in this case, we've wrapped it in an EM-defer, so now we're blocking a background thread, which means the main loop can still run. So what EM-defer is good for is if you have long-running computations, if you have a long-running process, if you do something that is potentially blocking the main loop, wrap it in an EM-defer block. The only thing that you have to remember is if you're doing I/O in it, the I/O has again to be rescheduled in the main thread. So sometimes your code will like ping pong between defer blocks and next ticks, because you're doing computation in a defer block, then you then having some I/O, so you do it in the next tick block, and then going back again with the result to a background thread. And if I would stop here, those are pretty much the basics of Eventmachine. Next tick, deferring, and then the typical callback stuff. So this is like the simplest thing that you can do with Eventmachine. But also, like for me, what I found myself is like the hardest part is finding out where your code is running and where it should be running. Yeah, sometimes if you have, as I said, a library, a class that you're requiring somewhere and calling out of an event machine loop, it's hard to define out now, am I now in the main loop, am I in a background thread, where should it be running? And it took me a while to like really get a feeling where it should be going. And so the main thing for you guys to remember is I/O in the main Reactor thread, anything that is potentially slow in a deferred thread. And if you're unsure, wrap it in a defer or in a next tick call. But there are a couple of like syntactic sugar, a couple of helper classes that makes it a lot easier to not get tangled in such a callback code. So a couple of those are deferrable queues, channels, and iterators that I want to talk about. And they help you to structure your code so that you don't get tangled up in all of those code, and it's very easy to make sure that you're calling the right code from the right place. So the first one is deferrable. Deferrable, at first it looks a little bit complicated, and it's hard to make out why you need it, but it allows you to write your libraries in a way that they feel like an event machine library, and that makes them very, very easy to use. What they are basically is like a mixture between a state machine and like a simple concurrency mechanism that allows you your own code to register callbacks and execute them when it's ready. So the idea is that I can register callbacks again, just like on the built-in event machine classes. So for example, I can register callbacks on a success case, and I can register callbacks on an error case. And the cool thing is that callbacks can be added at any time. Yeah, so I can create an object where I can register callbacks for successful and error cases. Doesn't sound too interesting, so let's look at an example. This is a very not too useful example. So I have a class, I include the deferrable module, and then I create an instance of it inside the run loop, inside the EM loop, and I just add a couple of callbacks. Yeah, a callback for success, a callback for error case, and then after 5 seconds, I make this deferrable object succeed, so that my successful callback will be called. So those are like the basic primitives that the deferrable allows you to do. So the interesting question is, why do I need stuff like that? Yeah, and the answer is to build classes that use again internally callbacks in order for your user to make it very easy to use them themselves. So let's assume I'm using the Google Spell Checker API. And because I of course use the asynchronous HTTP library to use it, if I would using myself, I would like to do a call to Google and then register my callback to be running, and then I parse the result and stuff like that. So this class is abstracting all this logic away from us. And using deferrables, I can use it like a built-in event machine library. So I can instantiate it. I can then call the method that is doing the work asynchronously, in our case, check, and then register callbacks that should be running once I get the result back. So my callback is getting all the suggestions and then printing them out. So very, very boring. But the code feels right. The code looks like it should be looking in event machine case. And it's implemented using deferrables. So the implementation is also very simple. I have my class that includes deferrable. Then I have the check method that does the actual asynchronous call to the HTTP library to the HTTP service of Google. And the interesting part is that on a successful HTTP call, I call succeed on myself. Yeah? I call succeed on the Google Spellchecker class with the result that I got from the Google service. And by doing so, all callbacks that the user registered on this Google Spellchecker instance will be called with the result. And the same would be true for the error case and so on. But this allows me to, so if my class uses like a very complex nested structure of event machine calls of like callback of callback of callback, I can still make it look like very nice and just notify the user when I'm ready, without the user having to keep track of all my internal state and to know where I'm in. Like, did I parse the XML already or not? And I'm still asynchronously, of course. So I hope that you understood what like deferrables are all about. So deferrables are just like syntactic sugar that makes it very easy for you to use a class that uses asynchronous methods, like in this case an HTTP request. Again, so this is the code that uses it. So so as a user of this class, I can just register a callback myself. I can just say, once you get back the suggestions from the Google Spellcheck API, this is what I will do with them. And I don't have to care how it's implemented internally. So deferrables are also heavily used by Eventmachine itself and by other libraries. So for example, the EM-HTTP request library that we're using right here is returning you a deferrable. So the HTTP variable is a deferrable, actually. So yeah, most of the Eventmachine libraries and protocol implementations actually return deferrables. And this is what's so nice about them, is that you can just like register callbacks on them and be called when they're ready. Yeah, another couple of things on deferrables is they have timeouts. So you can say, you can give a deferrable a timeout. If it's not succeeding within a specified amount of seconds, it will automatically fail. And you can also reset them, which is a nice way to like schedule work. So for example, the EM-Jack library, which is the Beanstalk implementation of an Eventmachine client, they use deferrables in order for you to be able to like instantly use the class without even having a connection established. Because you're just registering callbacks on the class, and once the connection is registered, all callbacks will fire, so the commands will be executed, you get the result back. And if the connection should like break or fail or time out, they reset the deferrable, which means all callbacks are cleared again, and then you can again register one of them, and once the connection comes back, all commands will be flushed to the server. So for you as a user, the API is very simple, very nice, but the behavior is very complex, because you're stacking up commands, you're firing them once you get the connection back, you're clearing them when the connection is lost and stuff like that. And it's very easy to implement those with deferrables. So if you're having a complex class that is doing a lot of callback behavior with Eventmachine, you should definitely think about using deferrables in order to make the implementation a lot nicer. Another thing that helps you structure your code if you're coding with Eventmachine are queues. So queues are exactly what the name says, a very simple queue, which is like in memory, so inside your process. But the nice thing about them is that they help you to make sure that the code runs in the correct place. So for example, it helps you to be sure that you're running in the Reactor Thread. So everybody can push to the queue, and you can pop of it, and you know the popping part will always be in the main Reactor Thread and can respond to the messages. The queue is very simple, so you just instantiate it. You can register a callback that will be run on pop, and then you can push messages onto it. The important part to know is that the pop part will only be run once. So if you want to have some kind of like a worker pattern where you continuously like execute something on items on the queue, you need to reschedule yourself. Just like in the example we saw before, where you're just having a proc, and at the end you're just executing the proc again. So in this case, we would be now continuously working off messages off the queue. And the pop part will be inside the main loop, inside the Reactor Thread. So you don't have, again, to worry, as I said before, because usually you have to worry, am I running in the first thread in the Reactor Thread? Where should I be running and stuff like that? So with a queue, it's very simple, so that you can schedule work from multiple threads, don't have to care where those threads are, and then work them inside the main Reactor loop. Another thing that helps you to structure your code are channels. So channels are a simple pub/sub implementation, again in memory inside Eventmachine. So they are not a replacement for like a real messaging application like AMQP and RabbitMQ and whatever. Yeah, they're just in process, but they help you again to structure your code. They make sure that subscribers and publishers can like safely communicate cross-thread with each other. So the idea is, again, I have a channel, and I can just subscribe to it. So I can subscribe from multiple threads. So I can subscribe out of the main thread, I can subscribe out of a deferred thread, and then I can, of course, push messages onto it. And as you would expect, I can, once I subscribe to a channel, I get the messages and can unsubscribe again. The way you usually use channels is if you want to have a long-running deferred thread that is doing like work that takes a long time, and you want to be able to like communicate your intermediate results to the main Reactor thread and do something with them. So usually you would then just publish out of the deferred long-running thread. You would publish to the queue, to the channel, and then you would have inside your Reactor loop. You would respond to the messages and process them. Another very useful thing that you can use is the Iterator. So EM-Iterator allows you to iterate over a set in parallel. So if you use the built-in iterator in Ruby, so let's assume we have an array of a couple of URLs, and we want to find out what is the biggest site hiding behind those URLs. Yeah. So for every URL, I load the page and I count like the byte size of it, or the size of the string of the body. In a sequential implementation, I would have to like call sequentially every URL, wait for it, and then at the end I could like find out which is the biggest. If you want to do this, we already learned that with Eventmachine it's a lot easier to do this in parallel, but still you have a lot of coordination work to do. Yeah, you have to keep track of the number of parallel threads. You have to somehow store the intermediate results, and then at the end iterate over those. And this is exactly like the shortcut that EM-Iterator gives you. So EM-Iterator allows you, is a built-in, like, syntactic sugar of wrapper to do this. So what you give it a range, and you give it the number of concurrent workers that you want to use, and then a proc that will work on the individual item in the range, and then optionally you can give it a second proc that will work on the result once all results are there. So the same example with EM-Iterator looks like this. I give it the array with the URLs. I say that I want to be processed in 10 parallel workers. And then I give it a proc that specifies what do you do with the individual item in the set. So in our case, we're doing the async HTTP call. And the important part is that we have to manually signal Eventmachine that we're done processing this part. So this is the iterator.return of the result. Because Eventmachine doesn't know when are we finished, so our callback has to signal that we finished processing this item. And the second proc gets all the responses once they're ready. So I don't wait for all responses. I can just register a callback again, and don't have to do all the coordination work myself, like coordinate workers, instantiate the deferred threads, like store somewhere the intermediate results, and then like recheck, are you ready with all of my URLs or not? So yeah, so EM-Iterator helps you to work through a lot of a range, or like of a set of items in parallel. Once you work with Eventmachine for some time, you should definitely start to look into fibers and EM-Synchrony. So once you understand all of it and you start to write complex applications, the problem is that you start. That's very easy to get into Callback Hell. So let's assume we have like a very simple task. Yeah, we want to search for a word on Google. Yeah, so this is an API, a very simple implementation of an API client to the Google Search API. We're doing an async request. We're loading the URL, and then we're doing a JSON parse on the results. But what happens if we now want to like load the first result? Yeah, so we have inside the successful callback, we have now to schedule a second request that loads this first URL and then prints out the size of the response, for example. Yeah, and once we have the size, we don't want to like print it. We want to like store it somewhere. Yeah, so let's store it in memcache. So again, we have an nested callback. So we have to now call memcache and register a callback that once the saving is done, we get notified. So it's very easy to get nested callback by callback by callback by callback, which is at some point it's very hard to look, very hard to read, very hard to debug, and to understand what is happening. Yeah? Especially if I'm now having only the successful case, only the successful callbacks. A good implementation, of course, would have to handle all errors in between. Yeah? So I have a very deep nesting of successful callbacks, of error callbacks, and so on. What you can do in order to avoid this is to use fibers. So fibers are part of Ruby 1.9, and they are also implemented in JRuby and Rubinius. And what they allow you to do is to make this code look like it's synchronous. Yeah? So it's a lot easier to read and understand, but the behavior is the same as before. It just reads nicer, which means it's nicer to understand and maintain. If you would use fibers in order to make this code look synchronous, is you have basically to resume the fiber on a callback and yield before you're getting your response. So it sounds complicated, but as you see in a minute, using it is very, very simple. If you would do it manually, it would look like this. You're instantiating a new fiber. Then you're doing the asynchronous calling and setup. And as a callback, you register a resume of your fiber, which means I want to now take back control in the fiber. Because what the fiber allows you to do is to voluntarily yield the control flow, in contrast to threads where in threading there is a fixed amount of time that you have to run, and after that you're going to sleep and another thread is running. With fibers you can schedule when those times are. So in our case, we say that on the last line that we yield the control back to the fiber that controls us, or to the main thread, because we're waiting for the response. And inside the callbacks, we said that we want to resume this control because now we got what we waited for. So the actual line of code is the last one that allows you to do this synchronously. So this is the complex implementation. If you would hide it in a method, it would look like this. So let's say we want to get an URL. So we put all this fiber code inside the method so that the actual API for the user looks a lot nicer. It says content equals get of URL. What it will do is it will behave exactly like our asynchronous example before, because what will happen is as soon as you call the method get, your fiber will yield to the main to the fiber that controls it, or to the main thread, and this code will suspend until the result is there of the HTTP call, and then your code is in control again, which means you can process the result. So the line content equals get of the URL, and then it could, of course, do the other processing with it. Looks like it's synchronous code, but in reality, you're always yielding control to the main fiber and getting it back once the result is there. Because it's very, very ugly to have all of those fibers everywhere in your code and to abstract away all of this functionality, there's a very nice library called EM-Synchrony from Ilya Gogoric that does exactly all of this for you. So it's already manipulating all the built-in clients of Eventmachine to do all of this exactly. So you just have to, instead of doing EM.run, you say EM.Synchrony, and you can write the code like it's synchronous. But in reality, it will do exactly the same callback and yielding stuff that we did manually before. The difference is that you don't have to see it. You don't have to maintain this deep nested code. The cool thing is, as I said, it's implemented for most of the, I think for all of the built-ins and for most of the big Eventmachine libraries, it already did all of this. So for example, for MySQL 2 and Active Record, it works out of the box for the EM-HTTP request. For the couple of MongoDB mapper libraries, and for EM.jax. So you don't have to to do that manually. Just by requiring EM-Synchrony and calling EM-Synchrony instead of EM-Run, you don't have to, you can use the synchronous looking code, but in reality it's asynchronously. What you can do with it is go a step further and use, for example, Goliath, which is an evented web framework by the same guys, so by Ilya and PostRank, that leverages the fibers and gives you a REC API on top of it that allows you to have a web framework that is evented by implementation, but looks like it is synchronous. So in this case, we have a very, very simple application that just responds with hello world. But we can, of course, have one that is a little bit more complex. And in our case, we're doing like a blocking MySQL query in it. But the cool thing is it's not blocking, because if this would be a Rails action, the Rails process would be hanging for 5 seconds. In Goliath, you can just hammer it in parallel and it will still respond to you because the fiber that is, so what Goliath is doing is it's implicitly wrapping every action call in a fiber so that that whenever you do something that is like blocking or you're handling control back because you're waiting on a response, it will yield and another fiber can run. So in this case, I can answer other requests still while waiting for this 5-second block. In contrast, if you would use Rails with it, Rails will now block and no other requests will be handled because we're waiting for this MySQL query. Yeah, so if you have something that if you have an application where you need a very high throughput and a lot of small requests, but you want to do a lot of them in parallel, you should definitely check out Goliath. Yeah, this is basically it. What I wanted to say in wrapping up is what you should definitely remember out of this talk, what I hope is that Eventmachine is a great library, but you have to always make sure, as a friend of mine, a colleague of mine, Matthias, is saying, do not block the event loop. Yeah, he's like yelling it constantly. But it's unfortunately, it's very easy to do so. Yeah, you have to be very careful not to block it. And sometimes, even if you do everything correctly, if you use only evented libraries, you make sure to use like Deferrables and stuff like that. It's very easy to just do too much work because you didn't test it with like thousands of messages processing at once or so to break it. So you have always to remember to not have any code that runs too long. So like to limit yourself, do a like EM next tick, like yield, and try again like in the next iteration. And the two important things are to know what EM next tick and what EM-defer does, and to know where to use one or the other, which means I/O and very small fast operations in the main reactor loop with EM next tick, and anything that is potentially longer running with background threads with defer. And all the libraries like the Iterator and the queues and channels help you to structure your code like this so that it's a lot easier to use. And I think with fibers and EM-Synchrony, it's a lot easier to use Goliath. And I think that you will see more and more applications using Eventmachine behind the scenes, but it will look synchronously with EM fiber. Yeah. Are there any questions? Yes, please.
Do you have any advice about testing these applications you build on?
Yes, testing. So testing is can be a little bit of a challenge because testing means you have to have a running loop. So what we usually end up doing is test all the domain logic, which is hopefully hidden well away in classes in normal unit tests that don't rely on the event loop to be running, where we sometimes just stop, for example, like defer calls or timer calls, like fire immediately. And then in your tests that test that you're calling the correct methods of the correct classes in the correct cases, there we actually fire up the event loop. And which means that usually you would set up assertions to run with a timer. So for example, my test would wrap it, so it would wrap an EM run. Then you would call the methods under test, like the instantiator class, and call the method that you're interested in. and have a timer that is scheduled like to run in like a second or so that has the assertions. So with an approach like this, you can test most of the stuff. For more complex interactions, what we do is we have like a real integration suite that actually fires it from the outside. So you're observing the behavior of, for example, are those messages processed correctly, and do I get like a different thing in my database? Where you're not like interested in the implementation of the agent of the daemon that you're using. You're just like testing the response of it. So I'm firing a message into RabbitMQ, and I say, like, 5 seconds later, there should be in the database something that looks like this. And how it implemented it or how it got there, I don't care. And with an approach like that, which is like the broader phase integration testing approach, we're pretty happy. It works very nicely. The only drawback is, of course, that at some point it takes a long time to run all your test suite. But if you nicely separate the domain logic and heavily use, for example, deferrables, which make it very easy then to have a clear interface that you can mock, it's very easy to have a unit test for the domain models and for all the domain logic, and then have a very lightweight test suite that tests that all your event machine setup code does the right thing and at the right places. Yeah, another question up here.
What's your strategy for exception handling?
Exception handling the question was how do we handle exceptions? Unfortunately, error handling in general in Event Machine is of course not the greatest because it's like sometimes deeply nested. So and you have to make sure that you're not killing your loop by having like an exception that you're not catching. So in general, the code that we use in Event Machine is very, very narrow. So what we tend to do is to have small agents that have a very narrow functionality or responsibility, and that ping-pong the work through a message bus, for example. So that the part that we have to test and handle is very small. And then those agents have a pretty rough general error handling that then, worst case, the agent is dying and we have to respawn another one. But in general, especially if you use like the fibers, the error handling becomes a lot nicer because it's not as deeply nested as before. So you can like check response values and so on. So we started to use fibers more and more just for the nicer error handling. But error handling is still a case that is not very great, especially if you get an exception somewhere deep down out of the reactor. Because, for example, a socket closed so an example is if you use somewhere a library that is not thread safe, for example, and you call it out of different threads, you can get like a weird exception out of the reactor because one thread tried to write on a closed socket or something like that. So this is definitely a case where you have to take care. It's not so easy to do with Event Machine. If you have very deep nested callbacks, and you have to take care of error handling on all levels. So my advice would be to limit the nesting and slice the responsibilities, have very narrow responsibilities, so you have defined interfaces. Yeah, another question? No other questions? Okay, so thank you very much.